Okay, in this video we are discussing redshift. So before we look at redshift, we are going to first look at something called the Doppler effect. Have you ever been stood at the side of a road when an ambulance rushes past you? If you have, you may have noticed the following two things. As the ambulance approaches you, the pitch of the siren appears to get higher. And as it rushes away from you, the pitch of the siren appears to get lower. So what's happening here? As the source of the waves moves towards a stationary observer, the waves that it emits get compressed. There are more waves passing you per second, so I've got a higher frequency and therefore my higher pitch. And as the ambulance rushes away from the observer, those waves get stretched out. I have fewer waves hitting me per second, so I experience a lower frequency and a lower pitch. If I was in the ambulance and therefore moving with those waves, I wouldn't get this effect and the frequency of my waves would remain constant. So the important things to take away from this are: when a source of waves moves towards a stationary observer, the frequency of those waves increases and the wavelength of those waves decreases. And when the source of waves moves away from a stationary observer, the frequency of those waves decreases and the wavelength of those waves increases. Okay, now we're going to think about that effect, but in the context of galaxies and stars. First, we need to look at something called absorption spectra. So, different elements absorb different frequencies of light. Here is my visible light spectrum. Hydrogen absorbs certain frequencies of this visible light. You can see the frequencies that the hydrogen has absorbed are represented by these dark lines. If you're interested, these specific frequencies correspond to the electron moving between energy levels in my hydrogen atom. And if you're not interested, don't worry about it. The point is, hydrogen gives me this very particular pattern. Now, when I receive light from a distant galaxy, my pattern changes to look like this. So as you can see, it's exactly the same pattern, but the wavelengths of the absorbed light have been shifted towards the red end of my visible spectrum. The red end corresponds to longer wavelengths, smaller frequencies of light. Remember when we looked at the Doppler effect and my ambulance earlier? When my ambulance was moving away, I got these longer wavelengths and shorter frequencies of sound. So since I've got the same thing here, longer wavelengths and shorter frequencies, this tells me that those galaxies are moving away from me. And if I look at a more distant galaxy, I see that this effect is even bigger. And the larger this shift is, the faster this thing is moving away from me. So, what have we concluded? Well, we've concluded that nearby galaxies are moving away from us, and more distant galaxies are moving away faster from us than those nearby galaxies, and hence our universe is expanding. And this redshift is a key piece of evidence in our discussions of the origins of our universe. Click on the next videos to find out more. Okay, hope you found that helpful. Please do download the notes, give us a like and subscribe. Thanks for watching.